Hi, welcome everybody. This is called Outrun the Bear, Performance Optimizations for Progressive Web Apps. This is camping bear-related theme because I gave this talk at that conference, which is like an outdoor camping type themed conference. So you're going to see a couple bears in this talk. And yeah, always got to click on the next slide for it to catch. So this is a little summary about the things that we're going to be talking about. We're going to talk about why performance is important. We're going to go a little overview on progressive web apps, how to measure performance, the cost of JavaScript, how to architect a single page app, and then some optimization examples that I've done at Comcast. There is a lot of material in these slides. There's 180 slides that I'm going to be going through pretty quickly. I will tweet out a link to the slides. It's useful for reference material. And throughout the talk, you'll see my handle down here, so you can tweet at me and know what my Twitter handle is often. If you have any questions, please hold them to the end. Come see me after the conference. I will be here all night, so love to talk about performance, love to check out your website, whatever you want to go through. A little bit about me. I believe in long-term relationships. I've been married to my wife for 7 years, been at Comcast for 11 years. I've been doing front-end development for 15 years. That was a little bit of a joke. Front-end developer with long-term relationships, relationship issues. OK, you might not get it. I got 2 kids, Theo and Josie. They are adorable and tons of fun. I work at a company called Comcast. You may or may not have heard of them. They are one of the largest TV internet providers in the United States. And I am based out of Philadelphia, which is 4.5 hours north of here with no traffic. And luckily, I hit no traffic. Going home, hopefully no traffic. And I work in this new building here. That's the Comcast Technology Center. That is dedicated for engineers at Comcast. There's about 4,000 people in there. There's a hotel, like this part at the top is a hotel. This part here is like Brian Roberts, who's like the owner of Comcast. He lives there. That's his penthouse. And then this is the Comcast Center right next door to it. Great place to work. We work on a lot of different things at Comcast. This is the Xfinity portal written in Ruby on Rails, just vanilla front end. My account for customers to view their account information, pay their bill, et cetera. This is written in Angular, Angular 1. Xfinity Home, this is written in Google Polymer using web components. This allows customers to manage their home. So this is actually my house. We have web cameras. I can turn on and off all the lights. I can change the thermostat temperature, all kinds of fun stuff. My wife's not paying attention to her phone because the child's having an emergency. I flash all the lights in the house to get her attention. That's good. That's how you do it. We also have XFi. We're going to talk about this a lot more throughout this talk. XFi is a portal that allows our customers to manage their internet settings. So you may have seen the commercials about the mom who wants to get the kids to the table and she shuts off the internet on them. That's what XFi allows you to do. And lastly, we have the stream site. So this is also written in Google Polymer, and it allows you to watch TV online. So why does speed matter? This is my daughter playing with some $100 bills. Sometimes you just have stacks of $100 bills sitting on the table that your daughter gets and starts eating, but that's OK. So like I said, I've been working in front end for a long time. This was the Xfinity TV portal back in 2012. And I remember the good old days where you would build a multi-page site, right? Like every page was an individual request back to the server. You would write JavaScript that would only work on that page. And when people clicked on a link, they would go to a whole new page, and new stuff would happen. And that was great. And the internet back then, the internet has gotten so much faster over the last couple years. Even with this only goes up to 2014, which is like 505 megabits. But today we're at like 2 gigabit speeds. So it's incredibly fast. And desktop processors. I love desktop processors. I can watch Twitch. I could have Twitch on another window on my machine, and it would use almost 0 CPU usage because all of it's offloaded to another core. Desktop processors are amazing. And then the best thing that's happened to the web over the last 10 years, this is now 10 years ago, is the Chrome web browser. I remember when this was first released and you would read articles, it's like, use Chrome. It's twice as fast as anything else out there. And every year they would have a new article like, it's now twice as fast as it was, twice as fast, as well as it's twice as fast as it was, twice as fast 2 years ago. And it's great, right? And so as web developers, we get to sit back, and even our Nintendo Entertainment Systems are getting smaller. We get to sit back and be lazy. We get to play video games, and who cares about the performance of our pages? And this is in 2016. There was this article about the average web page is the size of Doom. And this is about 3.16 megabits, so like 3.5 floppies. And also during 2016, something else was happening, which is the #1 traffic to your sites is now coming through mobile. And mobile phones are not as fast as desktop, nor is the internet as fast. As Alex Russell points out in his talk, how many people follow Alex Russell? I love this guy. He hates on mobile phone and web performance. Like he just like every tweet that he mentions is like, that's slow and it's awful. And there's a reason why mobile phones are slow. And the #1 reason is because they run off a battery. And batteries run out of energy pretty quickly. And there's a lot of performance optimizations that you have to do to conserve energy. Otherwise, your phone, you'd have to plug it in every hour. And the big thing is latency. So I really like this quote is, the problem with 3G and 4G networks is power, or rather lack of power due to the fact that mobile devices are constrained by their battery capacity. It takes a lot of energy to send information back and forth from your phone. And because of that, it adds a lot of latency. And latency is the time from the source sending a packet to the destination receiving it. This is how long it takes for packets to go back and forth. If you play video games and you start noticing lag, that's because the latency from your machine to the server is really, really slow, and you get fragmented experience. And for 3G, the average latency to connect to a website is 120 milliseconds. 4G, it cuts it in half to 60 milliseconds. 5G, which should be like 2 or 3 years from now, they actually are promising like 1 millisecond, but it will probably be like 10 millisecond average response times. So it is getting better, but it's still dramatically slower on mobile. And the same thing with iOS performance. So iOS chips, or this is iOS, Apple chips are the best. They are hands down better than Android chips. They have so much more memory, they're very fast, but not every person here can afford the latest iPhone XR, MX, Max, whatever the heck they're calling them nowadays. And most folks have phones that are 2 years old. Most people pay $200 for a phone. Not everyone is a technologist getting the latest Apple phone. So their devices are a lot slower. And there is an inherent need for speed in mobile, as DoubleClick points out, who's owned by Google. And the big quote that you may have seen is that 53% of users abandon a site that takes longer than 3 seconds to load. How many times, I don't know if you use public transportation down here, but I ride the train to work every day. And if you're on the train and you're pulling up a website and you're like, what's happening? You drop off because it's like way too slow. And there's another side of this, which is that mobile pages that are 1 second faster experience up to 27% increase in conversion rate. The faster your sites are, the more money they make. That you can go to your product and your owners and you can be like, we need to work on performance because the faster it is, the more money we make. Another thing is this tweet that was sent out by Adi Asmani a few months ago. And the important thing is not the big words at the top, it's this little words down here, which is that speed is now a landing page factor for Google search and ads. So if you care about where your search result is on Google, you need to make sure your site's fast. So I would argue that performance is your #1 feature, besides your site actually working and doing whatever it's supposed to do. Performance is your #1 feature. But it's more than that. To me, performance is very important because at the time I was building XFi. And this is an awesome site that, again, allows customers to control their gateway internet settings. And this is a progressive web app. It's a responsive site that looks great on mobile phones, and it weighs in at less than 1 megabyte. But I work at a large company, and we always do native as well. And I spent months arguing, well, why are we building a native version? The mobile responsive site works just fine. And so we released the native app version, and that's 75 megabytes in size. There's another portion of this, which is we actually force our customers to download this app to onboard their gateway router. So you have no internet, and we say, download this 75 megabit app in order to install the internet. And I'm like, what are we thinking? That's awful. But there is a reason for this, which I struggled with for a long time, and Owen has a really great article about this, is that you really need to build a native app and a website. And the reason is because websites let you get users, and native apps allow you to deeply engage. Because the truth is, you can't outrun a bear. They are much, much faster than you. They can run 60 kilometers an hour. They run faster than horses. Okay? They are incredibly fast. And the point is, like, the web will never be as fast as a native application. It's not meant to be. And this was really depressing for me when I learned this fact. And I climbed up a mountain, and I sat there for a long time. And I just pondered to myself, well, then what am I trying to accomplish as a web developer? And really, our goal as web developers is to get a site that is timed interactive in approximately 5 seconds, and that when you reload, it loads in 2 seconds. And time to interactive is how quickly a user can load and interact with your site. So a lot of folks will talk about server-side rendering, and a lot of sites might use server-side rendering. And what that does is it paints a screen to the user very quickly, but the user still has to wait for the JavaScript to download so that they can actually use the site. And it's still a poor experience for the customer because they're trying to click on stuff that you rendered to them, and they can't because there's so much JavaScript happening after the fact that it just doesn't work. And we need to understand that loading is a journey. We first click on a website on our phone, and we go from a blank white page. We want to show something as quickly as possible, have that first initial render. Then we want to get to the point where they can actually see our site and then interact with the site as quickly as possible. And that is our goal. And in order to get a site to load within 5 seconds, you get a maximum of 170 kilobytes of JavaScript and CSS that you can send down. So if you're over a meg in your one bundle that you're sending down to your site, I'm sorry, that's just not good. That's not good. You gotta trim it out. And we're going to talk about how to do that. But there's more goals for us as web developers. Is we want to feel like native apps. We want to be more like native apps, and that's where progressive web apps come in. So this is a progressive web app, and this is like a native app over here, and they're closer together. That's why they're sitting on a couch together. That's why I picked this picture. Just a little background. But progressive web apps give us this ability to add an icon to the home screen, to launch it with a splash screen, to go full screen mode without a URL bar at the top, to have offline mode and push notifications. And each of those, I have links to them so you can go through and figure out how to do progressive web apps. We're not going to go into depth about how to do each of those things. They're actually pretty straightforward. I'm going to have another talk on that at some other point in my life. But I must warn you that service workers are a bear to deal with. Okay, they can be very problematic because essentially service workers are another layer of cache. And we all know that in computer science, caching and naming things are like the two hardest problems. And whoever thought up like service workers would be a great idea of adding another layer of cache for web developers, I'm like, whoo. But there's a lot of things that you can do with them. One is caching and allowing your application to work offline. You can do optimization of images. So one of the cool tricks that you can do is you can actually check if the user's on a 3G network connection or if they have a high-speed network connection and send down different size images to the browser. And then the greatest part is push notifications. So you can actually send messages to the browser just like native apps can do. But I must warn you, if you do use service workers and you use one of the open libraries like SW Cache, be very careful because they can be dangerous. One of the things that we did on our site was we used SW Cache to generate a service worker file, and it by default automatically downloads every file that you publish, which was also the unminified versions of all our files. So browsers were coming to our site and then downloading like 75 megabytes of assets, even though they had no need for them. And yeah, we basically lit the forest on fire. Don't do that. But service workers are great for repeat views because they're, after the cache is already warmed up, they basically enable you to reload your site in under 2 seconds. And that's very easy to do with service workers. So the real focus of this talk is how do we get interactive in 5 seconds? And that's really the hard part for web developers. And the first thing that we need to know is we need to understand the tools that are available to us. And they start with the Chrome developer tools. The Chrome developer tools are amazing. I love the Chrome developer tools. Firefox also has great tools. I just work in Chrome a lot. And the first thing that you want to do is you want to measure the performance of your site. There was a great talk earlier today. I think it was Jordan gave the talk. Did anybody catch that talk? It was good. He talked about measuring performance because if you can't measure it, you can't improve it. And the big API that you want to use is the user timing API to measure performance. At Comcast, we actually have an open source library that we released called Surf and Perf. My colleague actually wrote that. He is a surfer, so he is legitimately allowed to call it Surf and Perf. And it's kind of like a play on surf and turf, like steak and lobster. For those who don't, I like steak and lobster. Yeah, I got a few grins from the audience, like, yeah, I like steak and lobster too. You know you do too, Jennifer. Okay, anyway, let's move on. So the Chrome developer tools also allow you to run a performance test. So there's a tab at the very top that you can't see up there called Performance. Has anybody used the Performance tab in Chrome developer tools? All right, so about a little bit more than half the audience have used it. So you can go in there, you can click a recording, and it will actually give you a complete rendering of all the stuff that's happening in the JavaScript and rendering world. First thing that you want to do is use incognito mode if you are going to do a recording, because those little extensions that you have in your browser, they actually show up on the timeline because they're built in JavaScript and they actually take up resources. If you use the user timing API, it's great because it actually puts marks in the performance logs. So it will tell you that from the user actually going to our site to when we mark the site to be ready, that took 3.76 seconds. And the great part is these metrics that we have, we can send them to our logging server and actually have real user metrics for how long it's taking for users on different mobile devices to access our site and how long it takes to load. The other thing is if you are doing user timing and you want to actually measure stuff, make sure that you are measuring the correct things. So here we were logging that our splash was dismissed at 2.5 seconds, but in the rendering up here, it was actually 3.1 seconds. And a lot of times what happens is developers will do dismiss splash and then log immediately that it was dismissed. What you want to do is you want to do on the next request animation frame. So allow the browser the time to actually render and then log that it was done. Does that make sense? I see some good head noddings. If you want to measure the performance of specific lines of JavaScript, use console.time. So you can actually put that at the beginning and the end of a function, and it will tell you exactly how long that function is taking to execute. And so the other thing that you can do to measure performance is use Lighthouse. Lighthouse is built into Chrome. It's the final tab on there. And it gives great information about what's slowing down your site, and it gives you a lot of hints about things that you can do to actually make your site faster. If you know nothing about performance, the easiest way to get started is to open up that tab, run that recording, and follow all the things that they tell you to do. And the other great part is Lighthouse is available as a CLI tool, so you can actually put it into your continuous integration environment, have it run on every build or every time you deploy, and then store the results of it so you can see your metrics over time. Because really you want to get to the point where you're deploying your site and you know that it takes 5 seconds to load, and then on the next release, if it takes 6 seconds to load, you can then flag it and say, we need to debug this and figure out why the increase in performance. All right, so now that we've measured the performance of our site, we need to understand what is affecting the startup time of our site. Anybody follow Adi Osmani? Yes, OK, everyone should follow Adi Osmani. He is one of the core engineers on the Chrome browser. He released a whole bunch of great articles about JavaScript startup performance. So he released JavaScript startup performance, and then he wrote another article called The Cost of JS. And then his most recent article is The Cost of JavaScript, because naming things is really hard as developers. So cost of JS versus cost of JavaScript. It's the same name, new article. But the summary of these 3 articles is less code equals less to parse and compile, less to transfer, and less to decompress. If you want to make your site faster, send down less code. And the reason for that is because of this great illustration about how the V8 engine works. And the V8 engine is the JavaScript engine in Chrome browser. So they take the code, the JavaScript code that they download off the network, they have to parse it, they convert it into a tree, which is like an actual Christmas tree with lights on it. Then they generate bytecode from it. They do feedback and optimization for it. So any functions that are being called over and over again, they optimize it further. And then they make it run on the different processors that exist. And so he has this great chart in there about how expensive it is to parse JavaScript. So on an iPhone 8, which has the A11 flagship processor, except for the A12 now is really the flagship processor, that takes about 4 seconds to parse the JavaScript on CNN.com. So 4 seconds. Compare that to the Moto G4, which is the baseline average phone of the majority of your users. That takes 9 seconds longer. It takes 14 seconds on a Moto G4. And even the iPhone 6 on here takes 12 seconds. So most users would probably have a device that's about 2 years old. It's a lot slower. And so really, as web developers, we need to pack less code. We need to get down from our doom origins of 3.6 megabytes and really start sending down less code to the browser. And that starts with your framework. So this is where I'm going to talk about frameworks. Sorry, everybody. So at Comcast, we actually have a mobile phone service. So this is Xfinity Mobile. How many people know about the Xfinity mobile phone service? So little shameless product plug. If you have Verizon phone service, this also uses the Verizon network. It's a great cell phone service where you pay by the gig. So if you don't use much gigabit speeds, you could probably save a lot of money by switching to Xfinity Mobile. Check it out. OK, product pitch done. So this website, this promotional website for Xfinity Mobile, is written with Angular. And it's like a promo site. And I love this site. I actually do random performance tests of different sites that Comcast produces because we're a large company. And so this is a site dedicated to selling mobile phone service. And it's a responsive site that should be fast on mobile. And I really love this site because it's a great slide where I ran a performance test. And because you assume that it's going to be fast because you're selling mobile phone service and whoo. Okay, so that site took over 30 seconds to load, which is just awful. And in order to do that, you can actually go into the performance tools and you can set the network speed to be fast 3G and a CPU slow down to 6 speed, and that will simulate like a mobile phone. So it's a great way of doing that. And this leads to this quote by Rich Hickey that programmers know the benefits of everything and the trade-offs of nothing. And he has this great video called Simplicity Matters that he gave at RVA a few years ago. And he really talks about developers today who just pull in libraries and they're like, oh, it does all these great things for me. And they don't really weigh the trade-offs of how does that affect the performance for the user. Because really, your users don't care if you're using Angular or Vue or React or RxJS or Redux or whatever these amazing terms are that we have today. They don't care. They care, does your site work and is it fast? That's all they care about. And so when you start evaluating framework sizes, you can look at how big they are and how long it takes to load. Because the bigger the size, the longer it's going to take to load. And Angular is about 57 kilobytes. And really, you want to get to smaller libraries. I'll wait for one picture to be taken. Awesome. And one of the smallest ones out there is actually Preact. And Preact has gotten a lot of popularity. It has a very similar API to React, but it's only 3 kilobytes compared to the 35 kilobytes of React. And Adi Asmani did some case studies with a lot of major companies who are switching to Preact because by switching from React to Preact, they get a 15% improvement in time to interactive alone. Imagine how much money they're making by speeding up the site by just switching frameworks with basically the same APIs, too. And it's more than just the framework that you're choosing, right? There's all the third-party libraries that you're also including. So the framework takes up a big portion of it. Then it's like, oh, I'm choosing React. Then I need Redux. Then I need React Router. Then I need RxJS. Then I want to use all these other libraries. And it's like you're bundling in so much stuff. And your core application is really just this teeny, tiny, tiny bit that actually makes the site work. So if you use Webpack Bundle Analyzer, it will actually show you all the JavaScript that's being bundled up and being sent to the users. So this is actually the bundle for XFi. And you'll notice that Lodash is being included. Make sure if you are including Lodash that you are using Webpack 3 or 4 because it will do tree shaking. Tree shaking means it actually checks which functions you're using and only pulls in those pieces of code. The Lodash library is 500 kilobytes in size. You're probably using 5 or 6 functions out of there. So you can reduce a lot of size by just doing some tree shaking by using the latest version of Webpack. RxJS is a very popular library that allows you to write like functional code. I am not against RxJS. A lot of developers like this. But know that it is 207 kilobytes in size. And again, your users do not care if you're writing functional code or imperative code or fairy code. It doesn't really matter to them. It just matters that it's fast. And again, I highly recommend that you upgrade to Webpack 4 or the latest version of Webpack. Webpack 4 bundles a lot faster than the previous version, and it also does tree shaking to reduce the size of your JavaScript. But today, as web developers, we're in this world where the average site is sending down 410 kilobytes of JavaScript. And we get 170 some, so that's about 3 times the size. So on average, it's probably taking about 15 seconds for the average website to load. It's actually worse than that. And this is where web components come in. So everybody went to my previous talk right before this, right? Where I talked about the Google Polymer project. And their motto, their goal is to get more developers to use the platform. And the great part about them is that the Polymer team sits on the same floor as the Chrome team. So they can actually build new APIs into the browser and prototype things very, very quickly. And the goal of the Polymer project team is to say, this is what we're doing today, is we're sending down a whole bunch of code with the framework. But what if the browser could be the framework? What if the browser offered new APIs that did more for you so that you could send down less framework code? And that's kind of the goal of web components. There are 4 specs for web components: custom elements, templates, HTML imports, and Shadow DOM. I will mention that you will probably never use any of these APIs, and nor do you have to. You should continue to use a framework, and the frameworks under the hood will start utilizing these APIs. Because those APIs are built into the browser, and they are closer to the metal, so they will actually run faster than anything that you can do in JavaScript. And the great part about these new APIs is that they are available in all mobile devices, where performance is the most important. So unless anybody is anybody using a Windows phone or one of the Amazon Fire phones? That was my point. Everyone is using an Android phone or an iOS phone for the majority. All right, so let's talk about some performance stuff. We built the XFi site with Google Polymer. I could talk afterwards about whether we would have used Google Polymer in the future. We're actually going to be switching to using React. So React is actually a really good library. I could go on for why React, and that's actually another talk that we give. So anyway, the XFi site is written in Google Polymer, and we followed a lot of best practices that the Polymer team produced. If you are interested in writing an app with Polymer from scratch, highly recommend you check out Kevin's talk. He's going to go on a lot of the best practices that I'm going to outline right now. The first one is the purple pattern. How many people have heard of the purple pattern? All right, I got like 3 or 4, so it's very, very low. This was the joke at the Polymer Summit. You always had to include like the purple slide. And this stands for push, render, pre-cache, and lazy load, additional content. And what this looks like on the timeline is you want to get to interactive as quickly as possible. So you push down the initial payload to get your site interactive. And then after it's interactive, you lazy load the rest of your site. You lazy load the additional pages. And how you do this is by splitting up your app into multiple bundles. So if you have a single page app, don't send down everything all at once in one bundle. Break it up so that you're sending down only the page that they requested first, and then lazy load the additional resources. And how you do that is following the app shell architecture. And this is you have your index page, which then will load up your shell for your site, and then the shell will load in the individual pages. So this is what it looks like visually, right? Is your shell is your navigation bar, the pieces that won't change with every release. You should have that in one bundle and be able to cache that for 30 days. And then your content, your overview page, your people page, your settings page, they can all be separate bundles that get downloaded separately by the browser and processed separately. And this is a good pattern to follow, but you can do even better. So a lot of applications follow this pattern, which is you have your top level root component, and then inside of your component, you're initializing all additional components. So you have your app, and then you do authentication inside of your framework, and then you start calling data, and then you show your login page or your overview page. And the problem with this pattern is that components and frameworks require time to start up. They have to boot up before they actually do anything important. And the critical path for our sites is we need to authenticate the user, and then we want to start making API calls as quickly as possible. Because the API calls for XFi site take about 3 seconds to get all the data back. And then we want to load the view. So in order to do that, we need to understand that the browser is still just a browser, and it processes things from top down. we pulled out all of our authentication and all our initial calls for data, and we made them just plain JavaScript that don't depend on a framework. It's all vanilla, so that way we can do authentication. We can start making those requests as soon as the browser hits our page. And then after that, the browser will download any polyfills that we need. Then it downloads our library of Polymer, and then it starts downloading the application. Make sense? Cool. And then after the application loads, we load just the overview page, and then we lazy load each of the different pages that occur on our site. And they can all be separate bundles. All right, so how did the XFi site do for performance? If anybody saw the previous site, it was not good. So when I first started this, it took approximately 6 seconds for the XFi site to load up on desktop. So the bear ate us over here. It's a little past the screen size. And the first thing that I did when optimizing the performance of our site is looking in the timeline. I saw this huge purple bar. And that was taking about 1.7 seconds to calculate styles. So purple is rendering time. And sometimes fixing performance issues is like looking for a 4-leaf clover. You have to spend a lot of time looking for it, and you got to hopefully get lucky to find the issue. And I actually found a bug in Chrome. And the bug in Chrome was based on CSS properties. So I mentioned this. This is a new spec that's in the browser that allow you to create CSS variables. And by default, Polymer sets all of them on the HTML tag and on the root element, which root is like higher than the HTML tag. And what was happening was it was taking 500 milliseconds to calculate styles using custom properties. But I switched one property. I added one property to the body tag, and it dropped it down to 65 milliseconds. And that property didn't actually do anything. It's just a property on the body tag, and it cut my styles by like 500%. But rendering is very important for performance. You want to have an optimal DOM tree, which has less than 1,500 nodes on the page, has a maximum depth of 32 nodes, and no parent should ever have more than 60 children. Does anybody here have more than 60 children? If you do have more than 60 children, that's incredible. I only have 2, and that is more than enough children that I want to have. Children are a lot of work. Managing children, the DOM doesn't like managing children either. So have as few children as possible. Another way to optimize performance, this is the people profile page. So it is a sub-page of the people page. And normally what you would do as a web developer is you would take that entity page and you would make it a child of the people page. And you would nest it as it was structurally on the site of kind of how the site is architected. But don't do that. Anytime you have a page that is a full screen page that takes over, make it a top level page. So you could have 30 pages that are directly on the top level router, and then you can switch between any one of those at any time. And the CSS styles will apply much faster because it doesn't have to traverse up the DOM tree. Does that make sense? I think that was kind of clear. Cool. All right, API requests. Like I said, the critical path for our site was getting data back from the server. So we actually had almost a full second where we were not processing any JavaScript or doing anything. And we have to make an initial call to the server, and then we get links to where to make additional calls. So this is another call that takes like 1.5 seconds, and then another call, so approximately 3 seconds before we can render. So you really want to optimize those network requests that you're making. And if I zoom in on there, we're basically downloading the index page and then waiting 150 milliseconds before we start making that first request to the API layer. And what you want to do is you want to figure out how to move that call up as high in your DOM tree as possible and delay all other work until you start making that API request. And some of the ways that you can do that is use preload or DNS prefetch. DNS prefetch will actually tell the browser to look up the host name, so it doesn't have to actually do a DNS request. The orange there is doing a DNS request. It takes about 15, 20 milliseconds. And you'll notice when it's actually calling our server, it already made the DNS request. So it saves us about 30 milliseconds, which is pretty good. Definitely recommend doing that. The other thing to watch out for is here we actually have the response returned from our origin server. And then it takes about 400 milliseconds before we actually start processing that response to make the next call. And the reason for that is the main thread is busy. JavaScript is single-threaded. Even though you make an AJAX call, the browser might not necessarily process it right away because it's busy doing other JavaScript work, especially if your framework is starting up. So we were optimizing making the network request as quickly as possible, and then it would come back in 30 milliseconds, but then we wouldn't make the next request because it was busy starting up our UI library. So we want to delay that work until after we make that second request when we have the time to do it. And the next thing you want to optimize for is when the network is done. So as soon as you get all the information back from the server, you don't want to spend time processing or booting up additional components. You want to render immediately. And here we were actually initializing additional components, and we should have been doing that during the downtime when we weren't doing any other work. Another common pattern is a splash screen. How many people have splash screens or like some kind of loader icon as your application starts up? Yeah, so one thing that a lot of developers do is they put that splash icon as part of the framework, which is what we were doing. So that splash icon was taking approximately 1 second before it started rendering to the screen. And really, you don't want to do that. You want to make sure that your initial render is not part of any framework. So you want to eliminate that. And so what I did was I actually made that just base HTML and CSS on the page that was part of the index page. And now I actually have that rendering in 0.2 seconds. So as soon as you request the page, it will show you that splash icon loading and base styles. And how you do that is you defer all the JavaScript on your page. Take all your script tags and put them at the top of your page. No longer do you put them at the bottom. You put them at the top of the page, and you put the defer tag on that. And what the browser will do is it will hit your script tags, it will start downloading, and it will continue processing the page. And it will actually process your JavaScript in a separate thread. So this is a great optimization. And it will still load those JavaScript files in the same order that they appear on the page. And another problem with splash icons is a lot of times you put that splash icon on there, but things will still be rendering. So here I'm showing like we have splash icon on the screen in the timeline, and this purplish stuff is rendering. And a lot of stuff is rendering. And it's like, well, there's only a little splash icon. What is happening? And what's happening is the splash icon is, or the splash screen is z-index over top of everything else. And everything underneath of it is still being rendered by the browser. And what you want to do is everything underneath of your splash screen, you want to set to display none. So the browser doesn't have to spend any time processing it or figuring out how to calculate styles for that. Another thing, recalculation of styles is very expensive. Recalculation of styles happens whenever you call certain properties or do certain things with JavaScript. So here, during our startup, we are actually forcing a recalculation of style. In the Chrome developer tools, you can click on this purple line, and it will come up and it will tell you exactly why recalculation was forced and where in the JavaScript. So here in our SI app, we were calling announce new content loaded. And I went into there, and one of the properties that was forcing reflow was called. So Paul Irish has a gist of all the properties that happen that forces a recalculation of style. So in JavaScript, if you ever ask an element, what is your width or your height or where are you at on the page, the browser immediately has to stop what it's doing and calculate styles. So you want to avoid doing that. During our startup, we were actually selecting an element and telling it to focus, which has the same effect. So it was actually telling the browser, hey, you have to recalculate styles now. And we were focusing it for accessibility to announce that we were loading, which was kind of problematic. You could just have your A11 reader just have I'm loading in there during startup. And this pattern was happening a lot where we were doing recalculation of styles, as you see all those purple humps up there. Another one was a third-party library that we were calling called iron fit behavior. And this was for modals and overlays. Everyone uses modals and overlays here, right? Yeah, they're great. And inside of the source code of this iron fit behavior was this attach function where they were calling getComputedStyle. And getComputedStyle is basically, OK, what is the width, height, and where is the position of this element on the screen? And they were doing it to check for text direction of whether the text is going from right to left or left to right. And the great part, I love making fun of this because the developer put in the comments, memoize this function, if I'm saying that right, which is a technique to store the result of a really expensive operation so you don't have to calculate it over and over again. But they did it per element rather than doing it globally. And we were loading this modal 27 times on the page because we had tons of different modals. So 27 times it was forcing recalculation of style, which I made the one change to remove that, and like, whoo, performance was much better after that. The other thing, after you do the initial loading of your site and getting that fast, you want to optimize transitioning between pages. So in the Chrome Developer Tools, you can click record at any time and then click on like another page and then stop recording and seeing what happened. So here, switching from the overview page to the settings page was taking almost 1.2 seconds to load. And that's just because there was a tremendous amount of JavaScript being processed there. It was way too much. And I was able to optimize that down to 255 milliseconds by knowing that this screen only has a little bit on there. And there were like sub-pages that were also being initialized at the same time. You really only want to initialize the components that are needed for that one screen that you're displaying to the user. Any sub-children, always defer loading JavaScript until you absolutely need it. Lastly, you should check out looking for optimizing expensive JavaScript. So here we have compare dates. And a lot of people like to use the Moment.js library. And they write functions like this, comparing dates and converting that date object to a moment object. And that's really, really expensive. So if you just use the built-in date operator for simple functions like this, you can save off 45 milliseconds, which is what I did here, because the function tree for Moment.js is really expensive. So this was initializing a moment tree, and that goes down really, really far. There's like lots of function calls that happen to initialize a moment object. But with some of the changes that I just outlined, I was able to get the site performance down to about 2.3 seconds to load. We pushed out a couple of those changes to production, and I'm happy to report that our average load time went from 21 milliseconds, and this is the 95th percentile. So it went from 21 seconds down to 15 seconds. So I was able to shave off like 6 seconds, which was really impressive to a lot of our managers and executives. I don't even work on this project anymore. I was doing it on the side. So it was fun doing that for another team. But the team has actually carried forward and did a lot of the additional optimizations that I had. So I'm really excited. They just did the splash screen one. So hopefully the next time I show this, it will be down to like 10 seconds. I highly recommend that if you want to test performance, you actually hook a real-world device up to your laptop. The Chrome Developer Tools allow you to attach to a USB device, and then you can do a performance test directly on a mobile phone. So in summary, we have about 2 minutes left. I really love my daughter's sleeping slide to make sure everyone's still awake and with me here. Anybody a fan of 37 Signals? They were like the original people behind Ruby on Rails. So they have this great quote: solving 80% of the original problem for 20% of the effort is a major win. The original problem is almost never so bad that it's worth 5 times the effort to solve. And I really like this quote because product teams will come to you all the time with like, add this feature, add this feature, add this feature. And you really need to ask, like, how many users will enjoy this new feature versus how much does it slow down the site? Do you really need this feature or not? Because your number one feature is performance. And you could send that back to your product team like, hey, we shouldn't do this because it's going to slow down the site by 1 second. The next thing is, like, it requires a lot of discipline to make your site fast. So this is an article by Pinterest, or Adi Osmani did with Pinterest about performance. And they have 600 JavaScript files, and all it takes is one ill-chosen import to like bloat your bundle. So make sure your continuous integration is constantly checking the performance of your site. And it's really, really, really hard to maintain performance. But also in that article, the 1-year retrospective of a PWA at Pinterest, they have this great quote, which is, in less than 6 months since fully shipping, we already have 800,000 weekly users using our PWA like a native app. There is amazing opportunity using progressive web apps and for development for front-end developers. Like, I'm really excited about what PWAs have to offer, especially if you optimize for performance and make them really fast to load. And that's about all I have. If you like this talk, I have a few other talks up on YouTube that you're welcome to check out. You can take a picture of the slides if you want this link so that you can actually reference the resource. Follow me on Twitter at ChiefCLL. I will tweet out all of these slides afterwards. And we are at almost exactly 45 minutes. Whew! And that was 179 slides. Thank you all for your time. If you have any questions, I'm also here for the rest of the day. You can ask me. Jennifer, do you actually have a question? Oh, yeah. So that was a joke last night at the speaker's dinner where We were wondering if bears eat deer. I didn't Google it yet. I will get back to you about that. I don't think that bears eat deer. Does anybody know for sure? They eat fish and like berries and stuff, right? And honey. Of course, honey. But yeah, I don't think they eat deer. But it'd be cool if they did. Because they can actually outrun a deer. Like, they're faster than deer. Any other questions?
Can you just go back to the previous slide?
Oh, yep. Yeah, feel free to take pictures of that. Back?
You have to give advice for the first two things you recommend people to do. What would be the first two steps?
As far as performance, like in general? Yeah. Okay, so the first two things that you should do to optimize your site for performance is use Lighthouse. So open up the Chrome Developer Tools, do an audit in the Lighthouse, and follow the steps there. And then the second thing is find someone else who knows what they're doing about performance to review and check out your site. I think the important thing is like doing performance at the end is very, very difficult. You really need to optimize for performance from the get-go.
I just wanted to ask if you are looking at this from a perspective of like a library author, is there anything that you can do differently?
That is a great question, which will lead into like why we're switching to React and using React. React is a great library. So from React 15 to React 16, they went from like 45 kilobytes down to 35 kilobytes. So they know that the performance of their framework is dependent on the size. And they're going to continue to reduce the size. And the great part about React is like Facebook is using it. They're not going to abandon it anytime soon. And they're going to keep making it better and faster. And all the authors, like the author of Preact, the library author, that was hired by Facebook to join the React team and make React faster. So there's great dividends and benefits to using React today. And like I said, you should probably not use web components in production or Polymer. You can use any one of the frameworks that you're currently using, and they will use this stuff under the hood, and they will constantly get faster and better. Angular 7 has the Ivy renderer, which is like 2 kilobytes. So all the framework authors know we need to optimize for mobile. And the other thing is, if you are building a site that is for desktop users, you are building an application that is mainly for internal, in-house, you should probably use Angular because it has a lot of things offered into it that's made for building desktop applications. But if your purpose is to build a mobile responsive site for customers, that you get millions of customers, then you can't use Angular. Like, hands down. Except maybe Angular 7 is probably a lot faster and better. Any other questions? And this is just my opinions based on my years of experience. Feel free to challenge me and say no.
So was it the conversion rate that made you say, oh, like performance, now that I can actually associate like some capital, some business, benefit.
Yeah, so I'll go into more detail. So the X-Fi site was struggling for performance to where the executives were like, we need to do more native app. And so how our native app works is actually, it was embedding our website inside of the native app. So the whole site was actually the website inside of the native app. And the performance of it was getting so bad that they made the overview page in the native app native. And I argued like, why? I mean, you just have to speed up the site. And so I spent the time to actually speed up the site, and then they were like, oh my goodness, we could actually make the site faster. So yeah, I think it's a hard sell because the team for X-Fi is like 30 front-end developers. It's also really hard to have 30 front-end people who know enough about performance to make the right decisions. Doing performance is really, really hard. So I think we're nearing the end of time. I want to make sure everybody gets to the next talk in time. But feel free to talk to me after the conference. I will be here for the rest of the evening, staying at the hotel and driving back to Philadelphia tomorrow. So make sure you talk to me before I leave tomorrow morning. All right, thank you all.